All right, so hopefully I can make a useful video here about the birthday problem. So there are two questions that are being asked. What are the odds that someone has the same birthday as me? This being, say, me, and this being, 10 other people. So there are 10 other people, so 11 people altogether. And then, what are the odds that some pair of people have a matching birthday? Let's do the first question first. So you imagine me asking each of these persons. And what we do is we answer a slightly different question. So we say, what are the odds that no one has, my birthday? And we know the odds of any one person not having my birthday is 364 over 365. This is, if this is, say, Jill, the odds of Jill saying, the odds of Jill not sharing my birthday, my B-day, are 364 and 365. And here's, say, Jim, and these are independent events, so we can multiply their probabilities to find out the probability that both Jim and Jill don't have my birthday. All right, so here's Jim, and this is Sally. There's another 364. Sally's answer doesn't depend on the answers before. And, there's, Mo. I can't randomly create names very well. And, etc. And I go through and I ask all these people. And the odds that each of them say no are pretty good. It's not surprising. The last person here will say Taylor. All right? So this ends up being the product, which we can use an exponent for. You don't have to, but it's to the 10th power. So what does that equal? This is going to be the odds that everyone says no. So it's going to be pretty good. We're not going to be surprised with this answer. It's 0.9729. So about 97% of the time, if I ask 10 people, is your birthday my birthday, they'll say no. So this means that the odds that someone in this group does share my birthday is 100% minus 97%, or 3%. So about 3% of the time, if I ask 10 people, is your birthday my birthday, I would find somebody that matches. This is not surprising. So let's look at a similar question that's not the same. So we'll look at the second question. Right. The second question, well, now we're looking for a pair. Now, how many different pairs can we make? Lots of them. We can make 10 pairs with me. Me and Jill, me and Jim, me and Sally, me and Mo, etc. So there's me and 10 others. That's 10 pairs. Now, after I've made those pairs, I'm no longer in the running. Now, Jim can make pairs. Jim can ask Jill, Jim can ask Mo, Jim can ask Sally, Jim can ask all of these different people. And that'll be 9 pairs. So, Jim and 9 others. And these questions that I ask or Jim asks all still have that same probability. It's still the probability of getting a no. Those are all independent. It's 364 to 365. And then Jill can ask. Now Jill won't ask me, and Jill won't ask Jim, but Jill will ask Sally, and Jill will ask Mo, and so on and so forth. So then there's Jill and 8 others, so that's 8 pairs. And then Sally won't ask Jill. That pair has already been done. Sally won't ask Jim. That's already been done. Sally won't ask me, but Sally could ask Mo, and then these other 6 people. So Sally can make 7 pairs. All right? And then so on and so forth. 6, 5, 4, 3, 2, 1. The last pair might be this person here. Maybe we'll call her Megan. So Megan is the second to last person. Everyone's asked Megan except for Taylor. Megan asked Taylor. There's 1 pair, the last pair. The odds of Taylor saying that's not my birthday are still 364 out of 365. Now Taylor doesn't have to ask anybody. Everyone has already asked Taylor, so Taylor doesn't make any pairs. So there are 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 pairs. How many is that altogether? That's a pain to actually add up. All right. There's a formula though for doing this kind of thing. This is the formula. And this equals 1 plus 2 plus 3 plus 4 plus 5 ... plus all the way up to n. So if you have n consecutive whole numbers and you want to add them up, you can use this instead. So in our case, we go from 1 to 10, then 10 plus 1 over 2. That's 10 times 11 over 2. Which is 5 times 11, which is 55. There are 55 pairs that we can make amongst these 11 people, this 10 plus 1. So there are 55 questions to ask, 55 comparisons. 55 questions or comparisons. The odds that all the answers are no is 364 over 365 to the 55th power. This is the probability that every single pair that compared birthdays resulted in a negative. Nobody had my birthday, nobody had Jim's birthday, nobody had Jill's birthday, nobody had Sally's birthday, nobody has Mo's birthday, nobody had Megan's birthday, nobody had Taylor's birthday. No match. Out of 55 questions, there were no matches. Well, what is that? So that's 360. Whoops. That's 364 divided by 365 to the power. And this is 80, essentially 0.86, or about 86% of the time. So 86% of the time, you'd expect all these answers to be no. This is the same thing. Then you take 100% minus 86%. That'll give you 14% of the time there'd be a match. Now if we compare this with the previous calculation, the odds that out of this group of people somebody shares my birthday, it's only 3% of the time. The odds that somebody shares a birthday in this group is 14% of the time. That's over 4 times the probability. It's 4 times as likely in this particular group of 11 people that somebody has a birthday. This isn't so great. This is about 1/8 of the time. So every 8 times you're hanging out with 10 other people, you'd find a match. At least one match, anyway. So I hope this has been helpful for working through that online quiz I gave you. Yeah, there you go.